Hello, good evening. I can see that I've got 3 viewers, which is rather gratifying. I'm sorry for being late. It's been a day of technical challenges, to say the least. And the technical challenges continue. Okay, so I have set up my telescope, and at the moment it's focused on the moon. I had intended to have a second telescope up and running, but unfortunately the technical gods have said no to that one, and so we'll spend some time this evening looking at the moon, and then potentially go across the sky and have a look at Mars, which is reasonably high in the sky at the moment. If anybody has any questions, I'll try to keep an eye on the chat box. So please feel free to type away. And just for starters, I think it would be quite instructive, quite nice to take a look at a sky atlas. So it's a program called Stellarium, which any astronomers will be very familiar with. Bear with me one moment and I shall add it to my screen. Okay. Right, so hopefully Stellarium's now visible. I've got a funny feeling that my screen resolution is all wrong here. Just forgive me for playing around for one moment. Okay, hopefully that's not too bad. So the moon at the moment is in Leo. If I zoom out here, we'll get a greater picture. The yellow line is the skyline from my location here. So this is something you can set up in Stellarium by photographing the sky and working out the coordinates of the roof line or the tree line, and then you can set this up as a landscape in Stellarium. At the moment I'm looking southeast, so the direction I'm looking at here is literally straight across to the city centre of Coventry. The green lines here are the celestial sphere, so straight up here is the what's known as the zenith, and the moon currently is on between 40 and 45 degrees in elevation. And as the night progresses, you'll see that the moon will gradually move across the sky towards the west. And will set in my location somewhere around about 3 o'clock in the morning. It will disappear behind the I think this is houses here, on the western side. So we're only a few days away from full moon. Go back to now. Here we are. So this is where we are now. Later on, we might get a chance to take a look at Mars, which is up here, and I also mentioned that we might try and take a look at a star cluster called M35, which is right, in fact it's there, in fact it's right next to Mars. So they're both in the same location in the constellation of Gemini. But to start with, let's go back to the Moon. Okay, so this is a live view of the Moon. Remove some of these other things that I don't want. Right, the telescope I'm using has a focal length of 1.8 meters, so about 6 feet. It's not actually that long physically in reality, through the clever use of mirrors, but it's a telescope with a long focal length. So this is what's enabling us to have a really quite zoomed in view of the Moon. If I zoom out a bit, we'll get the full view of what it can see. So this is the frame of the Moon that we see in this particular view. I'm tracking the Moon at lunar rate, but for some reason it's not tracking it perfectly. So I do have from time to time I have to go in and manually correct it. So what we can see here is a line known as the terminator. So it's basically the line between day and night on the Moon. Down here, towards the right, bottom right of the screen, is where the Sun is. So the Sun is shining up onto the Moon and casting shadow. When we get to full moon, the Moon is actually a lot less interesting to look at. Because none of the relief, there is very little shadow, in fact there's no shadow, and there's none of the relief, so it's hard to pick out the craters and the other geological features. So what I'll do now is take a kind of a brief visit along the line of the terminator and see what we can see. Now, something that I'm using which is extremely useful, it's only something I've discovered in the last few days, is a thing called the Virtual Moon Atlas. This is an absolutely amazing piece of software. It contains, it depends how many extra packs you load into it, but it contains a zoomable and searchable atlas of every feature on the surface of the Moon. So where we'll be looking today, as I said, is along the terminator here. You can just about see that there is a night side that's vaguely illuminated just here, and on this this sunlit border, the shadows are very long, so that gives us this great relief. Now, a good starting point, in fact, is this crater here. This is a really easily visible crater called Tycho, or Tycho, named after a Czechoslovakian, I think. Danish he was. Danish astronomer from 1600s, I think. My astronomical history is not too good. The crater itself is 86 kilometers across. Okay, so that's not actually Tycho there. Let's go and find Tycho on this side as well. Okay, so this is Tycho in close up. This is Tycho from a distance on the left. And you can see quite clearly that there's a central peak, and then the crater itself has these kind of tiered, terraced walls to it. The height of the central peak is 4,000 meters, so that's lower than Everest, but it's not very much lower. And the distance across is 86 kilometers, so it's pretty much round. and this would have been an impact crater. So some huge great asteroid or meteorite would have landed in here and caused some significant damage to the surface of the moon. So if I switch over to our telescope, let's go and find Tycho over here. Now Tycho's not quite on the Terminator, so the view of it isn't fantastic. But what I'll do now is I shall zoom in and see if we can get a better view of it. Here we go. So this is Tycho in real time. I can zoom in a bit more. In fact, let's go right in, see what we can see. Here we go. So you can clearly see the central peak. And if I flip back to the Moon Atlas, the central peak is here quite clearly, and with a bit of searching we should in theory be able to find some of the other craters. Two views are actually 90 degrees opposed to each other, so you can see here we've got 1, 2, 3, 4, 5 craters in a row, and back here we have those craters across the top of the screen here. 1, 2, 3, 4, 5. So that's Tycho. Not a great view at this angle of the moon. If we zoom right out though, we might be able to see one other feature. You can see what are called the ejector rays. So there's a clear one here heading off at kind of 1 o'clock, and a long one here down at kind of 4 o'clock, and one across straight at 3 o'clock, and one opposite at 9 o'clock here. And this is, as the name suggests, all the debris which was ejected when the impact took place. So you can get some kind of idea of it being an absolutely enormous impact. So the part of the moon that we're seeing is Tycho here. This is in the southern half. The moon is actually angled towards the sun slightly at the moment, and actually my camera's not completely rotated to be in the right aspect. But I had so many technical problems earlier on today. Once it was working, I felt like I didn't really want to touch it. So let's take another look now then. Let's move to somewhere where we've got a bit more relief. Now over here we can see a kind of long cigar shaped crater. So let's take a closer look at that and go away and find out some more information. Now this may be slightly cigar shaped, but I suspect it's more to do with parallax. It's as the crater's facing away to the side, we see it as an oval shape. Let's take a look in the Moon Atlas, and we should be able to see what it is. So it's this one down here, which is a crater called Schiller. Okay, so it looks like it is actually. It is a kind of cigar shape. So it's 179 kilometres lengthways and 111 across. You can see it also contains some sub-craters, so these are smaller impacts which have happened after the creation of the first huge crater. In case anybody's looking at this, I'm not sure if you can see the descriptions, they're in French. The reason for that is that this is a new release of the software, and I found a bug in it this afternoon while I was looking at it, which I've reported, and the developers got back to me to say if you look at it in French, the French database is correct, so they're going to go away and correct the English database, and the search facility will actually find the correct craters. So this, the incredibly impressive crater, and we're getting quite a view of it actually. It's an optimum view really this time of the month. Perhaps yesterday might have been slightly better, and then as we move up along the terminator here, we've got a very pronounced crater here, which is kind of joined up to this other crater on the side. Now, if memory serves me correctly, the crater we're looking at is called Gassendi. It is indeed. So it's 111 kilometers across. The size of these things is absolutely staggering. Now, unfortunately, I can't see or hear any of you, but maybe somebody could just put a message in the chat to say that you can hear me okay. Thank you, and I'm so glad it's working. So glad it's working. Okay, yeah. So as I said, we're looking at Gassendi, 111 kilometers across. I mean, the scale of it just blows my mind every time I think of it. And then the crater at the other end of that line is a crater called Messenius, which is slightly smaller. It's a round crater, 85 kilometers in diameter. But again, the height of the walls is nearly 4,000 meters. The scale is just incredible. Now, as we come a bit further along, this feature just here that we can see is known as the Sinus Iridium, which I think stands for Bay of Rainbows. Yeah, so Bay of Rainbows, and it's what's known as a gulf. So this I don't know for sure, but I think it may well have been a huge impact crater, which has subsequently been backfilled with lava. So this is relatively flat in the middle here. The size of it, again, is pretty gigantic. it covers an area of 237,000 square kilometres. So it looks small and quite possible to imagine here, but when you think about the scale of it again, and at such a distance, it's quite breathtaking. And then down on the end of it, we have a thing. I don't know whether we'll zoom in a bit more, but I don't know whether we can really appreciate it. Every feature of the moon just about has its own name, and this, oops, gone a bit too far there. This headland here, which you can just make out, it has a shadow on the side away from the sun, is known as the Laplace Promontory. Which is quite quaint. It makes you think of kind of seaside with a bay and a promontory on the end of it. And according to the Lunar Atlas, you can actually see this with a 50mm telescope. So the aperture of this telescope is 150mm, so it's 6 inches with a focal length of 1,836mm. So it's really a telescope designed for planetary observation and observation of the moon. Now, while we're looking at this, you can see, I think it's a lot more pronounced than it was before, that there's an incredible wobble, and the wobble is actually quite annoying at times. It's caused by the turbulence in the atmosphere, or what astronomers know as seeing. It varies from day to day. I photographed the moon a week ago. I think it was Sunday night and Tuesday night, and the atmosphere was remarkably still, incredibly so. And tonight seems far more turbulent than it was then. Now it reminds me of those kind of hand-drawn animated cartoons, Rhubarb and Custard and all that kind of cartoon, because it's in constant motion. Now the problem with this is, I mean, it degrades the view somewhat, but if you were wanting to photograph this, then obviously you might find that a single snapshot would be sharp. But in fact, if you took a snapshot at a point when the turbulence was particularly bad, you would just end up with a blurry photograph. So when we photograph these things, what we do is we photograph them as a video, and then we run the video through some stacking software, which will extract a given proportion of the best frames, the sharpest frames, and then merge all those together. And what comes out is a picture where the worst of the turbulence has been jettisoned, and then the rest of it we can process and sharpen up, and come up with a better photograph. Now, in this particular software, I've never done any kind of live stack from video. I normally use a piece of software called Firecapture. So I think actually that I probably won't inflict experiments on you tonight, the people who've turned up, and I'm absolutely gratified that anybody wants to listen to me. So thank you. So we've got a question here. What was the name of the moon software? Is it free? The thing that we're looking at the moment is SharpCap. It's SharpCap Pro. It is free. But if you pay an annual license, which I believe is £12 a year now, you get access to some of the better processing and other tools within the software. So let me see if I can demonstrate histogram stretch. So I think in the paid version, the histogram, which it's not so obvious with the moon, but if we were to go and look at, say, a nebula or something which wasn't so bright, then it would be useful to use this histogram stretch to basically open up the tones of the picture so that you could see some of the detail. and if you don't pay the £12, I think you don't get the chance to do that. And there are a few other things that that you don't get, but really, I mean, for £12, it's very, very good value. The other software I use for moon capture and planetary photography is called Fire Capture, which is completely free. It's a Windows program. If you use Linux, like I do if I can, it will also run on that in Wine, although it does have a few kind of weird behaviours in that. But on Windows, it's a superb piece of software, really very good. So that's Sinus Iridum, the Bay of Rainbows. So what I propose to do is, let's zoom out a little bit. Let's go and find one of the other things of interest. Now this is probably not the best night to look at it, but one of the most striking craters on the moon is called Copernicus. This is Copernicus here, and I think if your eyes are good, then you can actually see it without any assistance. Certainly in binoculars you can see this, so you don't need any particular equipment in order to observe the moon. The moon looks really good in binoculars, and a small telescope as well looks fantastic. And actually my own personal view is that although this is great to look at it like this on a screen, it's actually I don't know, it seems to make more impact when you see it for real with your eyes in a telescope. It has that kind of immediacy, and it feels very much like you're there with it, whereas viewing it on a screen, you're kind of once removed, if not more than once removed from the whole thing. But Copernicus is an absolutely huge crater, and if I zoom out a bit more, might get some idea of exactly how big it is. So you know, this is over here is Gassendi, which we were looking at. Copernicus is a similar size, and this is Tycho down here that we started off with. And again, Copernicus is demonstrating these various ejector rays. Okay, let's have another look at the virtual atlas, and go off and find something else of interest. Okay, so that was the Laplace promontory there, and where's Copernicus? This is Copernicus that we were looking at. And again, you can see if we were probably 4 or 5 days earlier, then the terminator would be more or less across here at Copernicus, and the view of it would be absolutely stunning. And same here for these mountains. They do have a name. I'm trying to think. Are these the Apennines? I can't remember. But it's a huge mountain range. And just flipping back again to our current view, these mountains are here, but because the sun is very much face onto them now, the effect of the shadows and our ability to see how high they are or appreciate the scale of them is really quite diminished. Where are we? So here we are. So this is our view of the mountains, more or less lit from the top. Now the trouble is, it's not clear every night. So I'd really love to photograph the moon every night for a whole month, so that we could really appreciate the effect of the terminator at all the different segments. So maybe you know, round about the middle of the month, we will be back round again, and we'll have you know, a better view of the mountains. Right, okay, so having said that, let's head off back up to the Terminator. We'll have a look at a couple of other things, and then we'll head off and see if we can pick up Mars, I think. So over here, this looks like, so this is a crater named after John Herschel, who was one of the great astronomers of previous times. Let's go and see if we can pick up the great big crater Herschel. So this again is another massive crater, 156 kilometers in diameter, but not actually very deep from what this suggests. So let's go and take a look. No, I think we're in the wrong place here. We need to be further around. So there's a sinus iridum, and that looks like, is that Herschel there? That looks like it might well be Herschel, which in our rather bouncy view is actually not that great from here, is it? Right, okay. Okay, so unless anybody's got any specific requests about the moon, I think it might be a good time to go and see if we can find Mars, see what we can see. Mars is likely to be far less spectacular than the moon. It's much smaller, obviously, and it's actually starting to get quite a long way from us now. A few months ago, Mars gave some very good views. Back in December, it was at what's called opposition, so it was as close to it as we get, and it was really quite dramatic. But again, the atmosphere is quite bouncy tonight, so maybe the views won't be that fantastic, but we'll see. So what I will do for Mars is I'm going to use a technique called plate solving. So what I'm going to do is disconnect from the camera here and move to another piece of software. Close camera. Okay, so my preferred software for astrophotography is a thing called NINA, which stands for Nighttime Imaging and Astronomy. Strange name, but a fantastic piece of software. So I've reconnected the camera here. What I'm going to do is come back to now in my Stellarium software. I'm going to go and search for Mars. Which is there. So once Mars is centered, I can come back here to a thing called the framing assistant, grab the coordinates for Mars, so it will pick those up. There we go, it's got the coordinates, and now I'm going to slew and center, and what's going to happen is the telescope is going to move itself to where it thinks Mars is, point to Mars, and then it's going to take a photograph and work out what it's looking at, and if it's not looking at the right part of the sky, it will then readjust itself and point in, and maybe it may take 2 or 3 steps, but it will eventually point to the patch of sky where Mars is, with Mars bang in the centre. Question from Simon: why is it rippling? Is that the atmosphere? Yes, it is. It's the turbulence in the atmosphere It seems quite bad tonight. A week ago, as I was saying, it was actually pretty good. In fact, it's two of the stillest nights that I can remember in the last couple of years. But tonight's quite bouncy. So there are, multiple layers in the atmosphere, each of them with their own winds, and then there's other kind of lower turbulence as well. So in a city, it's often quite turbulent because of the rising heat from the buildings. Now, probably at this time of year, it's not too bad. There certainly won't be much heat gathered from the sun in the tarmac and the concrete of the city, which rises and can cause quite a lot of turbulence. But it only takes strong winds at any level of the atmosphere to make the seeing poor and quite turbulent. It's not too bad, but it's not particularly brilliant. So on screen now, oh, here we go. Right, so the first time it missed Mars, but this time it looks quite clearly that it's found it. And it's taking another picture. So down here you should be able to see it says solving, so it's taken a picture. It looks like it was a bit bouncy. I suspect this might fail, and I'll kick it off again if that does happen. But once this process is completed, then we will be pointing at with Mars in the centre of the frame. It's taking some time to do this. We look at the image that it took, yeah, it looks like it started to expose the image for the plate solving before it had stopped moving, which strictly speaking it shouldn't do, because it's programmed to wait for 15 seconds before it takes another image. So I think I'm going to stop that and just start it again, and it will take a new image. Now, I'm not quite sure what we'll see of Mars, but this will be an interesting experiment. And in the chat I've just put a link to the Fire Capture website where you can download the software for free. Yes, the eight diffraction spikes. That's quite. I'm not quite sure why we've got 8 diffraction spikes. This definitely isn't the James Webb. But you're absolutely right. It's a similar kind of thing. Because this is a telescope with mirrors, so it's known as a classical Cassegrain. It has a big mirror at the back known as the primary mirror, and a small mirror at the top of the telescope, which is effectively at 45 degrees to the main mirror. So the light comes down the tube, hits the main mirror, comes back up to the secondary mirror, and is reflected out to either the eyepiece or the camera in this case. Because of the secondary mirror, which needs to be supported, it's supported with 4 veins of thin metal. That's what causes what we call diffraction spikes. So let's have a look. Right, so that seems to have found itself. Now, what I'm going to do now is I'm going to disconnect the camera here, and I'm going to go back to SharpCap. But before I do that, because we're looking at something a lot smaller now, I'm going to start guiding the telescope. So this is a second small telescope on top of the main telescope, which is going to lock onto a star. So this star here in the green box, it's found it likes, so it will lock onto that, and if the telescope drifts offline, it will send pulses to the telescope mount and pull everything back into alignment. So we should find that we don't drift away. And people get very obsessive about this graph, but I'm not going to do that tonight. So let's disconnect the camera, go back to SharpCap, and then let's see what we can find. Okay, so I was running at a very fast shutter speed before because the moon was so bright, and as a result, when we look at Mars, we can see nothing. So let's have a look. Camera controls, quick picks. Let's try 15th of a second, see what we get. Alright, okay, that's still not quite enough, but it looks like we do have Mars. Quarter of a second. Right, okay, Mars is starting to become a bit more visible. Let's try half a second. And you can see now that as the it's not overexposed, the diffraction spikes have actually disappeared. So somewhere in SharpCap there should be a way to restrict what we're actually looking at. Can I do it by just drawing a square? No, I can't. Okay, let's not worry about that. Let's zoom in a lot more. Let's zoom in. Right, okay, I don't think the views of Mars are going to be very good tonight. The atmosphere is very bouncy. Right, let's have a look. Let's play around with some of the camera settings, see if we can get it to look a bit better than that. High speed mode. Not sure what that is. Let's give that a try. So the going back to the seeing again, when you see stars twinkling, when you look up at the sky, if you're fortunate enough to live in a place where you can actually see some stars, the twinkling is caused by that very turbulence in the atmosphere, and the brighter the star, the more the twinkling seems apparent. Right, okay. Right, I'm finding this pretty unimpressive myself. I'm not sure about anybody else, but what we could possibly have a go at is, let's see if we can do what's called a live stack. So we're going to take a number of pictures of this and stack them all together. But before I do that, I want to see if I can set up what's known as a region of interest. I'm sure you can do it. In fact, I'll tell you what we'll do. No, let's see. I'll kick the live stack off first. Let's see if this works. Could not align yet. It's I think it's struggling. Yeah, it looks like we're not going to be able to do this on Mars. It's really just too bouncy. Probably too distant. Okay, no worries. What we can do is, let's head back to Stellarium. Let's pick another target. This is half the fun, I think, actually, deciding what it is you're actually going to look at. So let's have a look at Stellarium. Okay, do we have one thing that I think what we can do, this could be quite fun actually. Let's go and take a look at the Great Orion Nebula, because it's still just above the houses and it should be okay, I think. So I'm going to come back to here. Let's close the camera. Let's go and find the Great Orion Nebula, which is also known as M42. I think this is possibly the... Oh, it's very low, but we might just about get away with it. This is the brightest nebula in the sky, so it might be quite a reasonable one to go for. So we'll put in the coordinates for that. Slew and centre, and off that will go. We're getting quite close to the final days of Orion for this season. It won't be very long before it's just far too low in the sky, and then throughout the summer we never see it above the horizon. It's very much a winter constellation. It's actually quite exciting to see it coming back up in the sky in October and November. Aha, here we go. So yeah, we're not too far away. I think it's going to resync to get it right in the middle. Now, if anybody's familiar with Orion, let's take another look at Stellarium. You might be familiar with the shape of the hunter. So three stars in the middle here, the what's known as the belt of Orion, and then dropping down from there is apologies there, is his sword. And what we're going to be doing is looking at the middle star, or the middle illuminated part of the sword, and this is the Great Orion Nebula. Okay, so it seems to have centered itself okay there. So I'm going to disconnect the camera, and this time we'll go back to SharpCap again, and we will actually run a live stack. So a live stack can be quite dramatic with the right target. Okay, so let's zoom out so we can see what we're dealing with. And a bit more. Okay, so there we are. Now that's not very impressive as it stands at the moment, but we're going to need exposures. Let's try a 4-second exposure, and then we'll run a live stack. Okay. Right, so looking at this, hopefully you'll start to see the thing come to life. So the first 4-second exposure obviously was giving us not very much, and now what the process is doing is adding an additional 4 seconds of exposure, onto what's already there. So now we've got 45 seconds of exposure. And Julia, you'll be able to see on the bright stars that we've got the diffraction spikes back again, but now because the situation is not quite so extremely bright, that we just see the 4, so that's 1 for each of the vanes which support the secondary mirror. And in the centre of the nebula you can see four stars, a little star cluster. This is known as the trapezium. So that's generally a kind of test of your photographic ability, or your ability to focus. If you can see those, very often they will actually just merge into one blob. So we're doing okay tonight. In fact, I could probably zoom out a bit more because the nebula itself is actually very extensive. And again, this is impressive here, but again, you can see it in binoculars, and in a small telescope. It looks absolutely wonderful. The advantage of photographing it is that you see the colours. When you look at most of the things that we've seen tonight in a telescope or binoculars, they look pretty much black and white. The reason for that is that the human eye isn't really sensitive to many of the wavelengths of light, and also the human eye runs at a kind of 60th of a second, and it can't do fancy live stacking like we're doing here. So it can only register. Oh, and there goes a satellite through the middle. It can only register what it can see in 60 seconds. So there's lots of debate about is visual astronomy better than astrophotography, it's very much horses for courses. But Andromeda, I think, is too low now. It's an autumnal galaxy. It's one of the first ones that you can see as the nights start to get a bit longer. I'm fairly sure that it's way too low. Okay, let's go full screen. And in any case, Andromeda in this telescope, I would probably need to photograph it in a kind of mosaic, so it would probably take 10 or 12 different shots which would need to be stitched together. It would very much be a target for a smaller telescope. Right, okay, so yes, Andromeda from here is below the skyline. So I mean, if I lived in the desert or on a plain, then it might just about be visible, but it's really it's too late in the season, or too early in the season, whichever way you look at it, to photograph it now. Okay, so the stack's proceeding. Let's take a look and see if we can make it look a bit better. If I play around with some of the histogram. Oops. Right, okay, that looks a bit better, I think. So where are we now? We've got just exactly 5 minutes of exposure now. And I've looked at this target many times. I've only photographed it 2 or 3 times, but it never ceases to just completely bowl me over. It's just so fascinating. Okay, so if anybody's experiencing buffering, I've just had a message from YouTube to say that it's not receiving enough video to maintain smooth streaming. So let's see if I can do something about that. Thanks, Neil. Nice to know. Right, I'm still looking. Oh, good. Well, thank you, Julia. Right, and we can see that the anyway the nebula is starting to build nicely now. If I auto hide, let's get rid of some of these things. Don't think I need to touch those for a while, and let's zoom in and get a bigger picture. There we go. I don't think that's Starlink, Simon. I think that's just a satellite. We do see Starlink, and they tend to go over in kind of swarms. Often you can see 2 or even 4 satellite trails that are absolutely parallel with one another going overhead. But even without Starlink, there are still plenty of other satellites. Now, in this particular live stack, we've still got it. If I were saving these and then processing them afterwards, I would be able to, in the stacking process, eliminate any of the aberrations like that. So, you know, if a plane went across, or if a satellite arrived like that, the stacking software could filter it out. It may be possible in a live stream like this. I don't know. But whichever way you look at it, it's a nuisance, and it's only something that's going to get worse as time goes by. And you might also notice a few kind of weird looking blobs here, and this is dust on the sensor of my camera. And again, that's something that can be calibrated out in post-processing. But in a live stack like this, I think it's something that we have to put up with for the moment. But we're starting to get a sense of all the different colours of gas, and this is a young star forming region. And just to put this in perspective, what we're looking at is what we perceive as the middle of the middle star in Orion's sword. So the star below it is out of sight, and the star above it is out of sight. So it gives you a kind of sense of the vastness of the sky. So if we come back into here, let's have another play around with the histogram. If we make it slightly darker, we can improve the contrast a bit, and that didn't auto hide, did it? Right, there we go. But this is probably one of the most photographed nebulae in the sky. In fact, probably one of the most photographed objects in the sky. We're now starting to see some of the dark dust clouds. So we've got quite a prominent one here, and under this star over here, that you can see some quite prominent dust clouds. So where are we now? We're 11 minutes and 21 seconds. So while that's stacking, let's go and have a quick look at one I made earlier. Here we go. Right, so this is an image that was made in a similar fashion but done differently. So it was a collection of 33 minutes, which again is not very much, in fact. 33 minutes of total exposure. 13 of 2 minutes, 11 of 30 seconds, and 11 of 10 seconds to create a kind of HDR, high dynamic range image, to hopefully capture some of the bright and some of the less bright parts of the nebula. And this was done with a much wider telescope. So we're currently looking at probably just this central section here, and then in a much wider telescope, you can also see there's another nebula up here which has got the name the Running Man Nebula. So if you look carefully, you can see a head, arms and legs of somebody running away. Okay, so as we gain more exposure, I'm just increasing the dark point just to increase the contrast a bit, which makes it too much, I think. Okay, we've got a couple of choices actually. We can carry on just stacking here and see how this develops, or we could try another target. Not far from this one is a very well-known nebula called the known as the Horsehead Nebula. The red star. The red star, I think, is probably a fault on the sensor of my camera. If you're talking about this thing down here in the middle at the bottom, so it's probably accentuated in the live stack. If I was building this as a proper image, it would probably would definitely get calibrated out. So yeah, it's not supposed to be there. It's nothing exciting, I'm afraid. We'll just take a look here. So the guiding is okay. It's keeping things on track. It's not particularly brilliant, but again, with a bouncy atmosphere like we've got tonight, I don't think we'd get perfection. Right, okay, so where were we? So we're currently here looking at the lost jewel of Orion, just up here by the, let's zoom in a bit, by this left hand star of the belt called Alnitak. There's a nebula, this one here, IC 434, which is also known as the Horsehead Nebula, for obvious reasons. Now, if anybody's keen, we can go and see what we can see there. This is again one of the really frequently photographed nebulae, but it's absolutely wonderful to see. So I don't know if anybody wants to say yay or nay in the chat. Otherwise, we'll carry on with the Orion Nebula. One thing that is worth looking at is how close the moon is now, actually. I think we're fairly well away from the moon. Yes, the moon is over towards the east still, so we should be fine. Okay, right, we've got a couple of votes for the Horsehead Nebula, so let's go and see what we can find. So what I will do is I'll save that picture. Disconnect the camera. Let's go and see what we can see. Okay, so so up here I can also have a look and see that the framing will be okay. So this is more or less what we're expecting to see. It's going to be quite big actually in the frame, so yeah, that'll be an interesting thing to have a go at. So let's reconnect. Just hope it's not too close to the houses. It's starting to scrape across the top of my neighbour's roof now. We'll see. That's obviously not very close. I don't think we're going to see the horse head to start with, so it may not be as obvious as you might expect, because the nebula itself is actually not that bright, and in fact what we're seeing is a great big cloud of dust that's in front of the colourful hydrogen cloud that's behind it. Right, okay, so that it thinks it's locked onto it now, so that's fine. Let's go and see what we get. So it obviously is still above the houses, which is excellent. Okay, so zoom right out. Okay. Right, so that is underway. 32 seconds. Right, we'll have to let this run for a little bit, I think, before we get any kind of result. In theory, we might be able to pick up this pattern of stars in Stellarium to give us an idea of where we are. So if the framing is correct, we've got two fairly bright stars close to each other. See if we can equate that to what we're actually seeing. That could well be these two stars here. There's quite a strong gradient on this. I'm wondering why. We might have to be a bit patient with this one. It's not nearly as bright as the Orion Nebula. So what's that? 2 minutes and 20 seconds. Early days. Simon, you can still see the red star there, which is proof that it's something on the sensor and not something in the sky. And actually there's a couple more over here, a blue one and a red one, and there's a green one down here. So these are essentially pixels on the sensor. I'm slightly surprised we haven't seen anything yet, actually. If we look at this, so the magnitude is 13.98, magnitude 14, which in comparison to the Orion Nebula is a lot dimmer. It's not going to find it. Magnitude 4, yeah, there's a huge difference in brightness. So we might be being a little optimistic here, but let's run with it and see what happens. Still no sign of any horses. So what are we up to? 8 minutes 48. To be honest, I thought we might have something to look at by now. Yeah, I'm thinking that maybe the horse head is not going to work tonight, because apart from anything else, I think we're getting quite low, and the sky's going to start disappearing. So if nobody's got any objections, it might be quite a good thing. I was thinking of maybe having a look at M35, which is an open cluster, but that's actually fairly close to the moon. But one thing which is quite in a really good position is a spiral galaxy known as the Whirlpool Galaxy. So if nobody has any objections, I'll switch to that for the last few minutes. We'll probably wind up in sometime this side of 10:30, but we should have just enough time to grab some views of that. I think there's definitely no sign of the horsehead as yet. I think looking through lots of atmosphere as well might be, with contrast and so on, might be really expecting a bit too much. Okay, so let's drop out of this, go and find the Whirlpool Galaxy. And I mean, the Whirlpool Galaxy is spectacular anyway, so right, there we go. And the Whirlpool Galaxy is also at the best spot now. So you can see in this graph down here at the bottom, this line charts the height of the galaxy in the sky, and it's at an altitude of 84 degrees, so 90 is directly overhead. And one of the advantages of looking at it here is that we're looking through the minimum amount of atmosphere. So if you imagine looking straight up, that's the thinnest the atmosphere would ever be from this particular location. If we look at something which is at 45 degrees, we'll be going through 2 or 3 times more of this turbulent air, which would be affecting the views. Yes, and it's a bit brighter too. I think magnitude 14 or 13 or 14 was being far too optimistic. Okay, so let's head for M51. wide camera. You probably see the stars streaking overhead. There we go. So this is the small guide camera that's still photographing the sky, and obviously the telescope is slewing itself around to the new position. So once it stops, they'll turn into dots again. There we go. So the scope will settle for a few seconds, then it will photograph again and see if it's pointing where it needs to point. And it looks like it's a bit out. You can just see down here at the bottom of the screen the galaxy itself. So there are two galaxies: the big one, which is known as the Whirlpool Galaxy, and a smaller one which doesn't have a name. It has a category number, but the two are interacting. And once we get the image working, we should be able to see that quite clearly. Okay, so that's looking better. Is it happy with that? Yes, it thinks that's bang in the middle, and that looks about right to me. So the guide camera's up and running again now, so that's working, and we can go back. Disconnect from here, reconnect from here. Right, and off we go. I'm going to make the exposure slightly longer. It's struggling to align the frames because it's not capturing enough light, so I'm just going to push this. I think we should be, so 20 seconds. Okay, let's try that, see if that improves things. Now this is where the guide cameras are really useful, because, or I say useful, it's probably essential, because 20-second exposures with such a long focal length might end up with streaky stars, or stars which are shaped like eggs rather than round. But I think we need the longer exposures so that the stacking software can align the pictures as it takes them. So where are we? We've got a minute of exposure there in total, but we can see the stars are starting to appear, and then as we go on, the galaxy should too. That pesky red star's still there. Yeah, it seems to be stacking them up okay now. And in fact, those two blobby green stars that you can see just above centre, They are the two galaxies. So when we've got a bit more exposure under our belts, I'll play around with the histogram, and we will hopefully be able to see a bit more. And in fact, I don't know if it's very clear. Let me zoom in a bit. We can start to see the spiral arms appear now. Here we go. Oops, where's it gone? And the view is very green. It's not supposed to be green, but this is a colour camera, and it has twice as many green filtered pixels as it has red and blue. So once we've got a bit more exposure, I'll go in and tweak the colour balance. The reason that they appear green is a camera sensor. I mean, most of these, well, all these sensors are made for. I think really it's been driven by the mobile phone market. So they're designed to be used in kind of consumer items, and they tend to gather more green light because most photographs contain a predominance of green. So that the mobile phone camera can perform at its maximum, they're biased towards the green, and then the software inside the phone recalibrates it so it looks right, and that way it can gather as much light as possible. The same thing happens for us, but we have to do our calibration the same. We have to do the calibration ourselves rather, to achieve the same result, and this is just really proving the fact that for every one red and one blue pixel there are two green ones. So 50% of all the pixels on the camera sensor are set up to filter through and allow through only green light. But I think we've probably got enough there to start having a play around. So these sliders tend to be very sensitive, so I'm going to diminish the green, increase the red. Increase the blue a bit, I think. That's starting to look a bit more natural. Oh, I lost it. There we go. So the distance from us to this galaxy is 23 million light years, give or take 3.9 million light years, which is quite staggering. So the light that we're looking at now predates everything, really, certainly way before the dinosaurs. And so by inference, what we're looking at now, or what we're seeing now, might actually no longer exist. It's possible. It could have could have blown itself up completely and disappeared and maybe looked very, very different. But obviously the result of that wouldn't be seen on Earth for 23 million years. But we can now quite clearly see the two main spiral arms, so they they start here and here and spiral round each other. And over here we can also start to see the way that this other galaxy here has been disrupted by the gravitational force of this galaxy here. And actually each exposure of 20 seconds is now visibly adding detail. So we've got about 8 minutes there. Actually, just looking a bit further to the north, there are a couple of other galaxies. I'm not sure whether we're going to pick them up. Let's have a look. I think that might be one just there, a bit of a faint fuzzy thing. But there's also over here somewhere a galaxy which is edge on to us. I don't know whether we're going to be picking it up or not. Looks like we're not seeing it. Again, these are pretty dim. And the one I'm thinking of, Stellarium, doesn't even give it a magnitude. So maybe it is very, very faint. But I think this little thing here is definitely the other galaxy. But again, that's not particularly bright, so maybe it's just because it's end on, it's difficult to see. So what do we got? 11 minutes 50. I'll give this a few more minutes and then it's probably time to call it a night. Once we've finished, I'm probably going to put another camera on this particular telescope, and I think I'll probably photograph this galaxy throughout the night. It doesn't go below the horizon. It stays fairly high in the sky. So from say 10:30 to probably round about when's probably 4:30, 4 o'clock, 4:30. So there's potential of getting 6 hours of exposure on this, which will all be recorded as individual photographs of probably 2 minutes exposure, and then afterwards I'll have the job of stacking them all together in some software to produce a final image. Looking at this particular target, the stars look much rounder, so I think it's you know, what I said about going through less atmosphere here in this direction, pointing straight up. It kind of bears the proof that does produce much better images. Unfortunately for Orion, at this latitude, it's never overhead. In the swirl is stars, but I mean there will be gaseous parts of it too. I mean you can obviously see some big stars, but if you look at a Hubble image of this particular galaxy, you'll be able to see in much more detail what the arms are made up of, and you know they are stars, and it's very much like our own Milky Way. So there will be dust in there. Whether that dust is visible from this distance, I don't know. Simon, is there a black hole in its centre? I don't know, to be honest. I think many galaxies have black holes. I don't know. I'd have to research that. Certainly the search for black holes is, there's still a lot to be done. And I know that recently, in the last week or two, they've discovered a black hole which is absolutely massive, much bigger than they thought it was possible for a black hole to be, much more massive. So I think that's posed even more questions. But really, to get good images of these distant objects, you need to be outside of the atmosphere. That's why James Webb and the Hubble telescopes have been such groundbreaking devices. You know, they've allowed us to see things which really we would never ever have seen from on the surface of the Earth, even from the mountain peak observatories in places like Chile. There we have 16.5 minutes so far. I'll take it to 20 minutes and then I think I'll draw this to a close. So I hope it's been interesting anyway, and I must admit it's fun from my point of view to to sit with people and say, okay, what should we look at now? Let's go on a tour of the universe. And I've also learned that when we're live stacking like this, trying to do it on a magnitude 13 object through at a very low altitude is probably not the best idea. Yeah, thank you, Simon. You're very welcome. I'll certainly plan to do some more of these, and the great thing about the night sky is that as the months go by, we get different things to look at. At the moment, we're in what we call galaxy season, so the aspect of the Earth's axis is pointing us pretty much out of the Milky Way, out of our home galaxy, and we're looking outwards into deep space where all these other galaxies appear. And then as summer comes along, we will be then looking in the other direction, more into the centre of our galaxy, and the super rich star fields, and there's far more nebulae to see. So it's a completely different experience looking at the night sky in summer compared to winter, and autumn and spring again are the same. Thanks, Julia. Look forward to seeing you next time. Saturn is fantastic, Simon. It really is. Unfortunately, at the moment, Saturn is below the horizon. It's way over by the sun, so it's invisible. But once once the seasons change, Saturn will then start to become a morning object. I'm not so good in the mornings. I prefer to observe it in the evenings. But then everything's turning. So in the fullness of time, Saturn will come back, and this year Saturn was excellent. It was really, we had some really great views of it. Yeah, thanks, Neil. It's nice to know that you've enjoyed it. And if anybody does have any questions, then obviously you can. I'll save this live stream as a video that you can go and watch again if you want. But feel free to post any questions in the comments below that, and I'll do my best to answer them. Okay, so there we have it. We have our 20 minutes on the Whirlpool Galaxy to salvage the evenings from the jaws of failure at the Horsehead Nebula. Thanks for your company, and look forward to seeing you again. Okay, good night, everybody.